Hey everyone, welcome back to our Calculus 3 class notes. We're now starting chapter 15 on multiple integrals. So in section 15.1, we want to talk about double and iterated integrals over rectangles. Iterated integrals over rectangles. Okay, so what is a double integral? We're going to begin our study of these double integrals by considering the simplest type of planar region. So when we do a double integral, which you'll see later includes two integral signs, what we're doing is we're integrating over some portion of the xy plane, and we're going to integrate some function, a function of f of xy, which is defined on some portion of the xy plane. The simplest of these is a rectangular portion where x runs from a to b and y runs from c to d. Okay, so what you can imagine is, remember when we were breaking up a domain in just the x-axis with rectangles, we're now going to be breaking up the domain where now the domain's in the xy plane into these rectangles here that will have a height of the function f of xy. Okay, so what we'll do is we'll have this Riemann sum over this region R. So we're going to choose a point xk, y sub k that is in the kth small rectangle here. Multiply the value of f at that point by the area delta a sub k. So we're going to multiply the value of f to get the height times the area of the base. So we get height times area of the base gives us a mini volume, so a cube that goes above this rectangle up to the function f of xy. Okay. Add all those cubes together and we get a partial sum s sub n as k goes from 1 to n of all of these cubes. Then if we let the number of these rectangles increase indefinitely, in other words take the limit as n goes to infinity of the partial sum, we take the limit of that just as it shows. And what happens is, with kind of waving my hands here a little bit, which is completely fine, but it's very similar to what we did in Calc 1, you now get this definition of what's called a double integral. So we're integrating over the region R in the xy plane this function f of xy dx. So physically, just like the single integral of f of x dx gives the area under the curve down to the x-axis, the double integral of f of xy, this should be dx dy, by the way. Okay, this one should say dy dx. This one should say dx dy. It just depends which order you go in. Okay, so don't worry. This one should say dy dx right here. Please fix that in your notes. All right, and then what happens is it gives the volume under the function f of xy as it sits above that region in the xy plane. Okay. So let me come back on the next page and do that as another video.